Hello and welcome to Maths by SAS. This is my third lesson of D3, chapter number 6, exercise 6b, that is about the distance formula. I hope you have watched the previous lessons well and you have practiced the concept and the formula that how to find the distance between 2 points and the midpoint, because these all concepts are really important according to CI examination. Okay, let's move to question number 8 and let me read the question from the book. Question 8 says the distance between the points 1 and 2t and 1 minus t and 1 is square root 11 minus 90. Find the possible values of t. Okay. Let's try to understand the question. That in the question we are given with the points. One of the point is A and it has the coordinates 1 and 2t, and the other point has the coordinates 1 minus t and 1, and the distance between the 2 points is square root 11 minus 90, and we have to find the possible values of t. So first of all, what we have to do, we have to apply the distance formula on the given points. So according to the distance formula, the formula is d equals to x2 minus x1 whole square plus y2 minus y1 whole square, and then I have to put the square root on this. So if we look at the points which are given to us, x2 minus x1, so it means that distance between A, B will take the form, this is the second point, so 1 minus t minus 1 whole square and plus y2, which is 1 minus 2t whole square. Always focus on the formula and support your working with the formula so that examiner can understand your working easily. Now we can see that this one can go with this one. Okay, you must have to simplify the expression before going to the next step if you can, and we will left with minus t square plus 1 minus 2t whole square under root. Okay, now we have found the distance between the given points. Now because the given distance is equals to square root 11 minus 90. So what we have to do, we have to compare these two answers. Okay, now it's always good to support your working with small statements and phrases. This minus t square plus 1 minus 2t whole square and under the root equals to 11 minus 90. Now we can see the letter that we have to find is under the square root. So what we have to do to remove the square root, we will take square on both sides and the equation will take the form. Now let me simplify this as well. Okay, or let's keep it as it is and we will be simplifying the whole expression in the same step. Okay, after squaring, the equation will take the form 11 minus 90. Now both sides are free from square root. Now simplify left hand side of the equation, and equation will take the form t square plus, over here we have to apply the perfect square identity with differences, and the equation will take the form 1 a square minus 2ab minus 4t plus 4t square equals to 11 minus 90. Okay, solve the like terms. Like t square plus 4t square will give me 5t square minus 4t plus 1 equals to 11 minus 90. Now bring like terms on same sides. Okay, now 5t square minus 4t plus 90 plus 1 minus 11 equals to 0. And now what we have to do, we can see that we can simplify this 9t and minus 4t and 1 minus 11, and equation will take the form 5t square plus 5t minus 10 equals to 0. At this stage, we are getting the standard quadratic equation. Now, we can see that 5t square plus 5t minus 10, we can pull out, we can extract 5 as a common factor. So, the equation will take the form 5 into t square plus t minus 2 equals to 0. Shift 5 to other side, and now the equation will take the form t square plus t minus 2 equals to 0. This is the standard quadratic equation. Recall how to solve and how to factorize the quadratic equations and expression from D2, chapter number 3, 4 and 5. These lessons will be helpful in understanding this question, and please always integrate your lesson with the previous lesson for better understanding. Okay, now quickly what we have to do, we have to make the multiply this 2 with the coefficient of t square, that is 1. We will be getting the product 2, and then after getting the product we have to make the factors of 2 are 2 and 1 only. And now what we have to do, we have to set the factors in such a way that when we add or subtract, we get the middle term. So 2t plus 2t minus t, this will give me 1t, which is the middle term, and when I'm multiplying 2 with minus 1, I will get minus 2, okay, and which is the requirement of question. Now the left hand side has divided into 4 terms. Now make the groups of like terms and extract some number or letter as the common factor. Like from the first group, I can extract t out, and inside I will left with t plus 2 and minus, because both the terms are having minus sign common. So I'll extract it out, and inside the bracket I will left with t plus 2, and then I have to equate it to 0. Now we can see that t plus 2 is the common group. T plus 2 is the common group. Extract it out, pull it out. So t plus 2 into t minus 1 equals to 0. And let me move towards this side. Now the question and equation will take the form. Let me separate the place so that my working will not mix up with the other part. Recall the previous lesson that how we were solving the quadratic equation. I have to apply either or condition, either t plus 2 equals to 0, and this gives me t equals to minus 2, okay, or t minus 1 equals to 0, and shift 1 to other side, and that will give me t equals to 1. So I hope you are clear that how we are finding the possible values of t, and which was the requirement of question. Okay, let's quickly move to the next question, and let me read the question from the book. Question 9 says that given that the points A minus 1 and 2, B 5 and 2, and C 2 5 are the vertices of an isosceles triangle. Okay, then find the length of perpendicular from C to AB, and we have to find the area of triangle ABC as well. The first requirement is that we have to show that these points are the vertices of an isosceles triangle. Recall the concept of isosceles triangle, that what type of triangle is an isosceles triangle. Isosceles triangle is a triangle in which two sides are of equal measure, and equilateral triangle is a triangle in which all sides or three sides are of equal measure. Equilateral triangle. And then how to decide the triangle is a right triangle if the square of the longest side equals to sum of squares of other two shortest sides, then the triangle will be the right angle triangle. So in order to show that the triangle is an isosceles triangle, what has to be the first requirement? First of all, we have to find all three lengths, okay, or all three distances AB, BC and AC. If two distances or two lengths of the triangle will be coming same, then the triangle will be an isosceles triangle. Otherwise, we will see the situation that what type of answers we are getting, and we will be deciding the type of triangle according to the answers we are getting. And the second is find the length of perpendicular from C to AB. And then finally, we have to find the area of triangle. So let's move to the solution of the question. Okay. In order to show that the triangle is an isosceles triangle, first of all, we have to find the distances AB, BC and AC. Okay, now A has the vertices, minus 1 and 2. B has the vertices 5 and 2, and C has the vertices 2 and 5. Let's go for the calculation of all distances. Okay, let AB distance equals to D1. Now, if you look at the diagram, it's really good to sketch the figure according to the directions given. If we look at the A, B points, we can see either we can apply distance formula to find the distance, or we can find the distance between these 2 points graphically as well. Look, distance between A and B, from the right side we are having 5 units, and on the left side we have 1 unit. So the distance between A and B will be total 6 units. But let me assure this whether it is really 6 units or not. Recall the formula, that the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so according to that, what I have to do, x2 minus x1, that will become 5 minus 1 whole square plus 2 minus 2 whole square, and then I have to put the square root symbol here nicely. And now see, do not forget the rule of integers, that minus multiplied by minus will become positive, and 2 minus 2, when we will be taking away 2 from 2, my answer will become 0, and this part will vanish, and I will left with 5 plus 1 whole square and under the root, and this will give me 6 square, and then I have to take the square root. This square root and square will be cancelling, and I will left with D1, which is 6. And let me mark this answer. Okay, let me encircle this. And now let's quickly move to the second distance. AB distance we have calculated. Now BC distance, let's mark it with D2. And now carefully find the distance between B and C. Okay, x2 minus x1 whole square, that is 2 minus 5 whole square plus 5 minus 2 whole square. And now 2 minus 5 will give me minus 3 square plus 3 square, and this can give me 9 plus 9. Okay, and this is square root 18. This is not a perfect square, so we just have to decide at this stage whether the triangle is an isosceles triangle or not. So let this answer be as it is. Okay, and then I have to move to AC distance. Calculation of AC distance, that will be equal to D3. And now A and C, x2 minus x1 whole square, that will give me 2 minus and minus 1 whole square, and plus 5 minus 2 whole square, and then I have to put the square root symbol, and this will give me minus multiplied by minus is positive, so it will give me 2 plus 1 whole square, and then plus 5 minus 2, which is equal to 3 square. And now this will give me 3 square plus 3 square, and it will give me 9 plus 9, and this is square root 18. Now let me first block this answer, okay, and then I have to go for the decision that what type of triangle is this. If we look at all the answers, AB is 6 centimeter, B to C is square root 18, and A to C is also square root 18. As the two sides of the triangle are equal, so the triangle will be an isosceles triangle, because BC distance equals to AC distance equals to square root 18. So the triangle ABC, triangle ABC is an isosceles triangle, an isosceles triangle. The first part is done, and I hope now you are clear that how we will be deciding whether the triangle is an isosceles triangle, equilateral triangle, or right triangle. And now coming to the second requirement of question, that find the length of perpendicular from C to AB. Length of perpendicular from C to AB, it means I have to find the distance from vertex C to AB. Very easy question, okay. Now for this part, I have to see that what is the distance of C from AB line. AB line is at 2 units on y-axis, and vertex C is at 5 units on y-axis. Distance between AB line and C is of 1, 2, and 3 units. So the length of perpendicular from C to AB, second part, length of perpendicular from C to AB is 3 units. I hope you are clear that how am I deciding that this is 3 units. Okay, we have to find the distance of C from this line. Okay, now we have to see that C is at what distance from AB. AB line is starting from y is equal to 2. So from 2 to 3 there is a gap of 1 unit. From 3 to 4 again 1 unit, and 4 to 5 1 unit, and this is 3 units. Although the question is not asking this part, but I'm solving this because this is the most important part, and it's frequently asked in different questions, either in coordinate geometry or in trigonometry. And the third part is find the area of triangle ABC. Area of triangle ABC equals to triangle ABC equals to half base multiplied by height, and base we already have calculated, that is AB 1 by 2 into 6, and height is 3 units. Okay, and 2 ones are and 2 threes are, and 3 multiplied by 3 will give me 9, and as this is the area, so I have to put the unit square. So I hope you are clear about today's lesson. For next difficulty level and for better understanding of next lesson, you should practice this lesson really well, so that next lesson will be easy and clear to you. Please watch my lessons, like, share, and subscribe the channel, and press bell icon to get the notification of every lesson in time. And feel free to write your comments in the comment section for the improvement of the channel. Thank you very much.